Hi, and welcome to another edition of Technician's Toolbox. This is a continuation of our series on electronic throttle controls, focusing on the Chrysler ETC system. The electronic throttle control system was first used on the 2003 DR trucks with the NGC2 controllers and the 5.7-liter Hemi engine. Two accelerator pedal position sensors on the accelerator pedal input the driver's torque demand signal to the PCM. These two sensors are incorporated into one housing. In earlier systems, the sensors are located in the engine compartment on the left side under the battery. A cable connected the accelerator pedal to the APP sensors. Later systems have the sensor located under the dash on the accelerator pedal. These sensors are 3-wire linear Hall effect sensors that provide the PCM with 2 voltage signals in proportion to accelerator pedal position. Redundant sensors are used for their critical function. The signals from the two sensors are not identical. As the throttle opens, the signal from one sensor increases at about twice the rate of the signal from the other sensor. The two sensors have completely separate circuits with separate 5-volt references, signals, and grounds. The ETC throttle body includes the throttle plate, electronic actuator motor, dual throttle position sensors, gears, and a spring. The throttle actuator motor is controlled by a duty cycle signal from the PCM. A concentric clock spring applies force to close the throttle plate when it is opened beyond a nearly closed position. If electric power is lost, the spring will close the throttle to its default position. The spring also tries to open a throttle plate when it is fully closed. A word of caution: keep your fingers away from the throttle plate when the ignition is on. Do not open the throttle plate manually for any reason. Always use the scan tool throttle follower test to open the throttle plate. 2 throttle position sensors are built into the ETC throttle body and provide the 2 TP signals to the PCM. Again, redundant sensors are used as a fail-safe and for error checking. The sensors output analog signals to inform the PCM that the throttle plate moved as expected. The TP sensors are 3-wire potentiometer type and use a common 5-volt reference and sensor return. Each sensor outputs a signal in proportion to throttle plate position, but one sensor uses reverse logic. As the throttle plate opens, the signal voltage from TPS1 increases and the signal from TPS2 decreases. The sum of the 2 TPS signal voltages should always equal approximately 5 volts. PCM monitors this value to check for system integrity. The motor circuit reverses polarity to drive the throttle plate either open or closed. ETC connector pin 5 is the pulse width modulated side of the motor circuit. Motor circuit is completed through pin 3. Most of the time, circuit polarity causes the actuator motor to either open the throttle plate or hold the throttle plate open against spring tension. To accomplish this, pin 3 is grounded and pin 5 is powered. To reverse the motor and rapidly close the throttle, the circuit reverses polarity. Pin 3 supplies the 12 volts and pin 5 is grounded. Regardless of polarity, the motor circuit is always pulse width modulated on pin 5. Here, the key is cycled 2 times. Then it is turned off before checking the default position. The top waveforms here are the APP sensors. The bottom waveforms are the 2 motor wires. Red is pin 5 and blue is pin 3. With NGC2 PCMs, starter engagement may be delayed briefly at every startup while the PCM conducts an ETC spring test. Throttle plate is quickly driven open, then completely closed. The delay is approximately 0.2 of a second, and the driver may or may not notice this delay. Loss of any one input will cause the PCM to enter the fail-safe mode. The ETC system will limit throttle opening, slow the response to the accelerator pedal, drop engine speed to idle with brake application, and disable the speed control function. A DTC will set and the ETC warning light will illuminate. More serious faults will cause the system to enter the limp-in mode. In this mode, the ETC light flashes. A DTC will be set and the mill illuminates. The engine will run, but the vehicle can only be driven with severe restrictions. Speed control operation is not permitted. In the limp-in mode, accelerator pedal position has no effect on throttle plate opening or engine speed. The engine runs at 2 different RPMs with engine speed controlled by the action of the brake pedal. When the brakes are applied, engine speed is controlled at approximately 800 RPM. With brakes released, engine speed slowly increases to between 12 and 1500 RPM. The PCM controls engine speed by controlling the ETC motor, spark timing, and fuel. If the PCM cannot control throttle plate position, PCM attempts to control RPM with spark timing and fuel. The ETC system may enter limp-in mode for a variety of malfunctions. When servicing the system, disconnect the battery before replacing the throttle body. After replacement, the new throttle body must be adapted. Refer to the latest service information for specific procedures. This ETC system will not allow the technician to open the throttle by depressing the accelerator pedal key on, engine off. To verify operation of the throttle control motor, use the throttle follower test on the scan tool. In this mode, depressing the accelerator pedal will allow the PCM to actuate the throttle plate. For more information on the Chrysler ETC system, contact your parts supplier and ask them about Professional Technicians Seminar's one-night clinic on electronic throttle controls. Thanks for watching this video. Please catch the rest of the electronic throttle control videos at Technician's Toolbox.